Hello, this is Ms. DB, and in this video we are going to go over how to do a few of the problems from the Chapter 9, Section 6 worksheet. This is on geometric probability. So first we need to review a little bit of probability terms. So the set of all possible outcomes of an experiment is called the sample space. So the sample space is all the possible outcomes of an experiment. That's sample space. The set of outcomes is called an event. And also there's theoretical probability when all of the outcomes in the sample space is equally. Theoretical probability is what we expect to happen. So if every outcome in the sample space is equally likely, the theoretical probability of an event will be the number of outcomes in the event over the number of outcomes in the sample space. So it's how many you pick out of how many total there are, or how many you get out of how many total there are. So in geometric probability, we have three different ways to look at this. We could look at a line. We could say, what's the probability that when we pick a point or when we drop a pen on this line, that the point will be in between like B and C on the line. So the sample space would be all the points on the whole line. And we're looking for just what's the chance that it would land in this section. That's the event. So the probability is found by taking the event, the probability that it could land in that part, over the whole thing. So the whole thing is always on the bottom. That's the sample space. If we're talking about angle measure, then the sample space is any point in the circle anywhere. And we're just looking for what's the probability that it would land in this region, in this shaded region. So there's an angle measure that would be given in that circle that is in this little sector here. And that angle measure of that sector right in here over 360 degrees, because every circle has 360 degrees. So if you're dealing with an angle measure of a circle, the numerator will be whatever the angle we're given, and the denominator will always be 360. And then the third type is when we're looking for the area. So there'll be a larger sample space, in this case it's a rectangle, and then they'll give you a smaller figure and we want to know what's the probability that it'll land in this smaller figure, this triangle, out of the whole sample space, which is a rectangle. So you need to find the area of the triangle, you need to find the area of the rectangle, and then write and simplify the ratio of those two areas. So on this worksheet, the first part is finding the probability that your point would land on a piece of a line. So your whole line is over here. So let's see, a point is chosen randomly on EH, that's the whole thing, and you would need to figure out how long is this line. Well, from E to F is 5, from F to G is 1, from G to H is 2. So you add all of those up to find the denominator. So 5 plus 1 is 6, plus 2 more is 8. So I already did number 1. The point is on FH. Well, FH is from here to here. 1 plus 2 is 3. So the chance that it would land on FH, I take the probability of that event over the whole line is 8. And then that's 3 over 8. And then also write that as a percent. To write that as a percent, here's a little review. You would do 3 divided by 8. That's the decimal number, 0.375. And then move your decimal point over 2 places, or you can just multiply by 100. Whoa. To change to a percent. So 37.5% is the percentage. That's the probability that a point chosen randomly on this line would be on FH. And you're also going to, if it's not, you would just subtract from 1. The probability that it would land on EH is 1, because 8 out of 8 is 1. The probability that it's not on EF, that would be 1 minus 5/8, or you can just look at the piece that would be left if you took away EF. And then you can do 3 and 4 the same way. My worksheet does Seem to have given me a big space there for some reason. All right, then the next section is when we have a circle. We have this circle and it's divided into sections. Why is my circle up here? There we go. Okay, it moved on me. So remember that there's 360 degrees in a circle, so that is going to be your denominator. The probability that the pointer would land on the 135 degree sector is 135 over 360, and then you simplify it and then you write it as a percent. If it, like in number 7, it's two parts, 30 or 75 degrees, then you would add those two probabilities together. So I would have 30 over 360 plus 75 over 360. And then you would add those together to get 105 over 360. And then you need to simplify that fraction and then change it to a percent. Same thing for 8 through 11, except instead of the degrees, they're giving you some letters for those, but you would still solve the problem the same way. Remember to read carefully. If it says not, then it would be all of those besides that. So you can either say 1 minus 65 over 360, or you can find these three added together. And then the last section is on area. So we're going to use area to find geometric probability. In this example, we have a triangular area inside of a rectangular area. And they want to know what is the probability that a point chosen randomly inside the rectangle would land inside the triangle. So you need to find the area of the triangle and the area of the rectangle, and then write that as a ratio and simplify. So you need to know your formulas that you should have written down by now in your notes. And the area of a triangle is 1/2 base times height. And the area of a rectangle, you can either do length times width or base times height. So the area of the triangle would be 1/2 6 times 3, which is 9. And the area of the rectangle is 10 times 5, which is 50. So the probability that a point chosen at random would it be inside the triangle would be 9 over 50. And then you can also write that as a decimal or as a percent. So for the next few problems, you'll be doing that exact same thing. In number 12, you need to find the area of the square and the area of the rectangle, write it as a ratio, and then change to a decimal. You can also write it as a percent if you want. In 13, you'll be finding the area of the triangle and the area of the rectangle, write it as a ratio and simplify. In these problems here, they all have to do with this figure over here. We have two figures inside of a rectangle. We have a circle and we have a trapezoid. The large rectangle area will be the denominator. So that's easy enough to find. Area equals base times height. Find the area of the circle and find the area of the trapezoid so that when you do the rest of this problem, it'll be easier to compute your ratios and then simplify. When you get to number 16, it says, find the probability that a point chosen randomly inside the rectangle is in the circle or the trapezoid. So for or, you will add the area of the circle over the whole rectangle, plus the area of the trapezoid over the whole rectangle. You'll be adding those two areas or those two ratios together in order to find the total amount. Not the circle and not the trapezoid is this shaded area here. To find that, you will take the area of the rectangle, which is just 60, 6 times 10, and you will be subtracting the area of the circle and also subtracting the area of the trapezoid. And finally, the last problem, we are going to find that the probability of a point chosen at random from inside the circle will be inside the triangle. So here's the triangle. The circle has a radius of 5 feet, and the triangle has a base of 2.5 That's from here to here. And height of 5 feet. So the height of this triangle is equal to the radius of the circle. So if you find the area of the triangle by using 1/2 base times height and the area of the circle, pi r squared, then you'll be able to write this as a ratio and then change it to a decimal or a percent. So these are really not very difficult. It should be a good review of all of the different area formulas that you may have used in this chapter, as well as some reminders about some probability work that you've maybe done, but we haven't done much this year. So this is geometric probability. Please let me know if you have any questions. Thank you very much.